Okay, ladies and gentlemen, I am joined today by a very, very special guest indeed. And we are going to be joined by somebody who's been on the show before, and I just love getting into really deep and scientific conversations with. You know, if you listen to this show, this is my favorite topics to get into: space, quantum, the multiverse, all that stuff like that. And there's certain rock stars out there. And today's guest is our personal scientific rock star on the show, and his name is Brian Keating. And Professor Brian Keating is Professor of Physics at the University of California, San Diego. He has lectured in 6 of the 7 continents, including Antarctica. Now, he's an expert in the study of the universe's oldest light, the cosmic microwave background, which he uses to investigate the origin and evolution of the universe. Now, Brian is a pioneer in the search for the earliest physical evidence of the inflationary epoch, the theorized period of expansion of space in the early universe directly after the Big Bang. And it was in search of evidence of this inflationary epoch that Brian came into very close contact with the Nobel Prize. Now, I don't want to spoil the kind of story here. I'll get Brian to explain what happened after that. But I can tell you that it led him to write the book Losing the Nobel Prize, which, get this folks, it was Amazon's #1 science book in the 2018. Now, if this wasn't enough for all of us to really sink our teeth into, Brian is also the co-associate director of the Arthur C. Clarke Center for Human Imagination, hosting a podcast called Into the Impossible that covers the world of arts, sciences, humanities, engineering, and medicine on the nature of the imagination and how, through speculative culture, we collaborate to create the future. So then, without any further ado, let me bring the man himself onto the show. Brian, it's great to have you back, man. And like I was saying there, you truly are one of my rock stars of science on the Kev Baker show, dude.
Oh, that's an honor that I'm going to put above the Nobel Prize, Ken.
I'll tell you, well, by the end of today's show, people might actually agree that the accolade that I've just given you is worth more than the Nobel Prize. But Brian, talk to us, man, because this is a kind of very special anniversary, or it's the eve of an anniversary for you, right?
Yeah, the book, which, I never thought I'd write a book. I never thought it would be, #1 bestseller on Amazon. I never thought it would be selected by Science Friday and Amazon, et cetera, for all these accolades, especially since it's about, kind of the shunning of accolades and really the problem, the perniciousness of these accolades and what it does to young people. I'm not so young anymore, but in my colleagues and the young people I mentor and how obsessed they are with the Nobel Prize. And, I never thought, well, the book, if it was read by a couple hundred people, it's more than almost any paper I've ever written. You have to realize, what an audience size is for you. A number of times a scientific paper is referred to in the literature is to me, and other scientists. So the question of whether or not it would sell 100 copies, and that would be more than most papers that I've written. And it was thousands and thousands and thousands. And, that's great for my, bottom line. I got hungry mouths to feed, et cetera. But really, it's the widespread applicability of the action that I've mentioned in the book, and somewhat gratifyingly, hearing from people on the Nobel Committee themselves and taking issue with me for the first time in public. That's been a surprise to me, that they've never taken issue with critiques that they've received, even from people far more famous and well-known kind of scientific pundits than myself, including Nobel Prize winners. But for the first time, to my knowledge, a Nobel Academy representative, a man by the name of Goran Hansen, took the time to respond to an article, and maybe you'll put a link to it in the show notes. I'll send it to you later. And this was the first time in history. So they're taking note of my book, which is great. But of course, the thing that drives me is not the Nobel Prize. I've come to, grips with the shortcomings, the foibles, all the disagreements I have, and actually no longer pursue it specifically. But
well, Brian, really for somebody like me, and I'm sure a lot of the audience, and until I met you, I was always a believer that, when you heard that a physicist or a scientist had a Nobel Prize, that this was the be all and end all. That this was like the highest honor that could be bestowed on any scientist out there. And it almost adds some gravitas, some weight to anything that they say after that. Now, would you say
That's
that
right.
putting so much kind of respect towards the Nobel Prize is due? What's your take on it, sir?
Yeah, I've really come around, 180 degrees from that perspective. I did used to, as I recount in the book. First of all, the book's mostly a memoir of what it's like to be a young scientist and wrestle with issues of family and love and pursuit of knowledge, not just the Nobel Prize. But there are 3 chapters out of 13 that are dedicated to that. And, the anniversary that we're on the precipice of is the publication of it in paperback, which is just amazing to me. I never thought I'd write a book. I never thought it would do well, and I never thought it would come out in paperback around the world. So it's really exciting for me, and I'm just enjoying the ride. But the Nobel Prize, just for those listeners who may not know, is really not only science's highest superlative honor in literature and peace and economics, allegedly, but it's the world's highest honor of any form. You hear people talked about it in almost a deity-like state, where it's become this religion, as I recount in the book, which is replete with the highest kind of veneration, worship of people, ideas, and in some cases, they worship ideas that are quite awful and turn out to do things that are quite bad for humanity. I go through things in the Nobel Prize that led to, basically the lobotomy and how that was applied to people with mental illness, not just, mental diseases, but illness and just incredible harm that was done. And it would not have been done in all likelihood, according to most people, without the prestige afforded by this procedure winning the Nobel Prize, let alone people that have gone to the greatest heights of achievement in physics, for example, and then turn their attention on awful things like eugenics and wanting to advocate for how certain groups should be sterilized or encouraged to be sterilized. And that would not happen for an Oscar winner. In America we have an Oscar ceremony. You don't hear the Oscar winner saying you should do this medical procedure on people from a specific race, or it's just awful things. And in our case, in science, it often distorts the perils and pitfalls and the reality of science and turns it almost into an award show, which it basically has become. So I think you're going to hear a lot about it in the next 2 weeks as it comes time to award this year's Nobel Prizes. And there's no shortage of controversy that surrounds these most prestigious of any kind of award. I don't care what it is. Nobody cares what somebody who won an Emmy award has to say about eugenics or something like that. So it's just an incredible thing. And I went back and I did a historical search. And I said, well, how prestigious was the Nobel Prize compared to winning an Olympic gold medal or winning a Pulitzer Prize? And how these awards have kind of decreased in fame and renown. You can't name anybody from your home country mostly that won a gold medal in the Olympics 4 years ago, but you might be able to name Peter Higgs or somebody who from Great Britain who won a Nobel Prize, and justifiably the winners I have no problem with because they don't select themselves. In fact, I was asked to nominate winners of the Nobel Prize. Shh, don't tell anybody because it's supposed to be confidential, and the Swedish mafia may come out to get me. But the preclusion of nominating myself means that these people, men and very, very, very few women who have won the Nobel Prize, they are really not self-selected. So I have no problem with them. It's not their fault in a sense, but it is the fault of the Nobel Committee, the way that they manipulate the way that science is interpreted, and in some cases, the prestige that the world affords to things like the Nobel Peace Prize, for example.
And I was quite shocked to hear you say, and of course, we've done previous episodes, and I'll link them in the description, where we've gone into detail about the experiment and everything else that led you to becoming that close to getting the Nobel Prize. But I was quite shocked when I was cramming some of your latest interviews today to learn that actually, to win the Nobel Prize, I think you stand a far higher chance of even being considered if you're lucky enough to be taught by or mentored by a previous winner themselves, right?
Yes,
And that
yes,
just
that's
doesn't
right.
seem fair whatsoever.
Yeah, so that's an example of this famous effect called the Matthew effect, where the rich get richer. In this case, it owes itself to a little-known statute in the Nobel nomination process, which is that if you win a Nobel Prize, unlike any other human being on Earth, and you should know that, by the way, there's no like underground volcano where this is decided by the most brilliant people who have ever lived, and then they sprinkle in some Eye of Newt and and you get out the right answer. This is really constructed a prize that is defined by the whims of 400 mostly male. People don't like it when I say they're mostly white, but it is true, and there's been very few minorities, unfortunately, that have won this recognition. I say unfortunately, but it's done a lot of damage to people that do win it. So it's be careful what you wish for, but nevertheless, it's just a fact that these 400 men in Sweden, largely men, there are a few women, they are 100% unilaterally responsible for making the final call on who wins the Nobel Prize. However, they do take input from people like me. A couple hundred physicists around the world are asked each year to nominate people that are worthy of winning the Nobel Prize in their opinion. And then nobody knows what happens to our suggestion. Our identities are sealed for 50 years. So if I didn't write this book, no one would know that I was a Nobel Prize nominator. And you don't know who are the nominees for 50 years either. And I point out that's longer than the JFK assassination files were kept closed. Why is that? And it's because they want to protect, they want to defend, they want to procure, this aura of invincibility and complete omniscience to this group of 400 Swedish scientists. And it's really kind of a shame that we put so much stock into what these 400 people say as if they're some sort of godly entities, which they surely are not. They make tremendous numbers of mistakes.
I think what we'll have to
But
call them is like the Holy Order of the Nobel Prize.
I call them the Swedish cabal. I call them the Swedish mafia. But specifically when you asked about if you work for a Nobel Prize winner, so there's one category that's eternally eligible to nominate, and that's if you won a Nobel Prize in the past. Every year you can submit a nominee for the Nobel Prize. So there's a woman, Harriet Zuckerman, who's done studies that show the likelihood of winning a Nobel Prize if you worked for or with or had a student that was a Nobel Prize winner. And it's much higher than sort of the stock and trade average physicist, for example.
And I also heard you mentioned the Matthew effect there. And then today
Yeah.
I heard you talking about something new to me called the Matilda effect. And this ties in with what we're talking about here, right?
Yeah, exactly. So the Matilda effect is sort of the poor get poorer, almost the opposite effect, specifically with respect to my women colleagues, my female colleagues that have, only had three winners in the past 117, 18 years of the Nobel Prize's existence in physics. So last year, thankfully, a woman did win it, Donna Strickland, for very, very important work in fast laser dynamics. But besides that, there were women that had not the last woman to win it was here at my home institution, Maria Gephardt Mayer in 1963. So, you're going to have 50 years plus between women Nobel Prize winners. And that in part has owed itself historically to women being overlooked and their discoveries being credited to a man. So what happened was, in the case of most of the Nobel Prizes that involve potential women winners, they're either their PhD advisors. In the case of Lady Jocelyn Bell Burnell, she discovered pulsars using a radio telescope built by, in combination, several people, but her advisor. And then she discovered the data unequivocally showed this existence of this fast, incredibly powerful rotating radio beacon. And she presented that information for her thesis and to her advisor. And he and another man ended up winning the Nobel Prize in part for this discovery. And it's just astonishing how many times that men in history have gone on to win the Nobel Prize due to the discovery that a woman, in the case of this discovery I just mentioned, and perhaps most famously Rosalind Franklin. who discovered without her data, they would not, Watson and Crick and Wilkins would not have discovered the helical structure of DNA. And we can get into that and how the Nobel Prize Committee is rewriting history and claiming that they do not make, that the justification for why, say, Rosalind Franklin did not win a Nobel Prize is rational. They never write back about Jocelyn Bell Burnell because she's still alive, and there's nothing that precludes her next week of winning of being awarded the Nobel Prize in Physics, but they won't do it.
And this opens up a bigger conversation, really. And I've seen a lot of talk about sexism in the games industry and in technology in general. And you've been somebody on the front lines of science, Brian. I mean, what's it like in the scientific field, cosmology, astrophysics? I mean, is there still so much sexism like we're told?
There's a lot of imbalance. There are, kind of classic cases where there have been astronomers that have been accused of sexual harassment, misconduct, ranging from Neil deGrasse Tyson, who recently was accused of certain bad behaviors, shall we say? I know it's a family show, so I won't get into it. And also, people like Jeff Marcy in the United States. And these are always men that have had a challenge when it comes to, I shouldn't say challenge, I mean, if they're guilty, I don't know the facts. These cases never really come to the
That's what's
come to
so horrible about this
yeah.
current kind of climate, isn't it? There's all these accusations, and then it leaves a stigma attached, and sometimes it's warranted, and sometimes it may be baseless claims. It's so horrible.
That's right. And so you don't know who to believe. And then you'd think a scientist would be one of the foremost people to want to come to a pronouncement of innocence and evidence. And these things are still murky. There are always these accusations. Lawrence Krauss, another famous cosmologist in America, was under allegations of sexual harassment within the secular humanist or atheist community not too long ago. So it does suffer, and it does no one really any good if you don't come to a resolution on it. And in all these cases, the facts are still very murky.
So tell me then, what else about this Nobel Prize? Because you've wrote this book about it. I mean, what other issues are with the Nobel? I mean, what would you change about it if you could, Brian?
Well, it's so interesting. I wrote an article for this online magazine called The Conversation last year, and I said I'll link it. And the Secretary General of the Swedish Academy, who's one of the major institutions responsible for awarding the Nobel Prize, wrote me back. And basically, I went through some of the arguments I make in those 3 chapters of my book, that the Nobel Prize has a historic, propensity to overlook the contributions of certain groups in favor of other groups, for example. And many mistakes have been made. And the rules have been changed completely arbitrarily many, many times in the past history, except to rectify the ways that things have been done wrong in the past. For example, Alfred Nobel said the prize should go to one person. Well, they said, well, we should only give it to 3 people because we should, allow for the fact that there's more people doing certain scientific or medical research or whatever. But that made the problem worse because it's one thing if you're the only person on a project, to win it, and then everybody else loses it, and it was clearly your idea. Versus like 3 people, as happened with the LIGO discovery of gravitational waves. And then the committee, I did an interview with Alex Filipenko, who was the only human being on both teams to discover the accelerating universe due to presumably dark energy, using supernova at great distances that explode and act as beacons across the universe that tell us how fast the universe was expanding in the past and that it's accelerating now and getting larger and larger as we go into the future. So Professor Filipenko at UC Berkeley, he said that when he went to the Nobel ceremony, he was kindly invited by both teams to go, even though he didn't win the Nobel Prize. And when he got there, he said that many of the committee members, when they're drunk, will say things like they agree with sort of the suggestions that I've made, including the fact that more than 3 people should be able to win it. He was a member of a team of 2 teams, each one about 30 people. And so there's 60 people that they thought could be, theoretically eligible. And the committee members told him crazy things like, well, sometimes we wait long enough thinking that some of the key people, if there's a 4th person, that they'll die. And that actually happened not too long ago. So, in the LIGO discovery of gravitational waves from these inspiraling black holes that we talked about maybe a year ago now, that discovery was really the product of about at least four people, could be plausibly attributed the Nobel Prize. And yet it was awarded to three of them because, luckily, with very sick quotes around it, for the committee, one of the members and the founding members is a Scottish physicist by the name of Ronald Drever. He passed away essentially about 11 days, earlier, too late rather, for him to win the Nobel Prize himself. And because of all these strictures that they put in, for example, you can't win it posthumously. There's no law of physics, Kev, that says, if you die, the day before the ceremony, your results are totally invalid. But that's the way this committee treats things, total capriciousness. And that's part of something that's inherently anti-scientific.
Yeah, how inconsiderate of those black holes. If only they'd gone 10 days sooner, right?
Exactly.
That's insane. But
Yeah.
you are a cosmologist, and there'll be people out there thinking, what on earth's name does a cosmologist get up to? So tell me, what's your typical day, Brian? I mean, what do you do
Yeah.
at work?
So most people think, cosmologists, they want me to give them tips on their hair and makeup or, something like that. And I point out that it's true. Cosmology and cosmetology share this prefix, cosmos. And it's not like some random coincidence. It's because the word cosmos in Greek is a prefix and it means face or beauty. And so when people are going to the cosmetologist, as I know you do every day because you're so handsome, and I confess, my hairstyle needs an update,
Oh,
but
trust me, I've got a radio face.
you have a face for podcasting. So that is a beautiful face, just like the beautiful face the universe presents to us. In my case, we study and acquire data that have come not just across the Earth or in our laboratories or across the solar system, but don't even get interested in something unless it's about 1 billion light years away. In other words, we're looking back in time by seeing light waves that have been traveling at the most rapid rate possible, 300,000 kilometers per second. And we don't care about something unless it's traveled for at least 1 billion years or more in order to probe what's happened deep in the cosmic history bin. And in our case, we're looking back even further, back to when light itself was released to our telescopes, the earliest light in the universe. And that's called the cosmic microwave background radiation, or CMB radiation. It's a type of signal that pervades the universe in all directions at all times and all seasons. And it has properties that encode what was the physical condition of the universe when it was produced nearly 14 billion years ago. So it's a very precious fossil. And we act like archaeologists looking back in time, but we use telescopes instead of hammers and brushes and shovels or whatever archaeologists use.
I was fascinated. You gave a talk at Google, and here we are on YouTube, obviously a subsidiary of Google. And the mere discovery of the CMB, the cosmic microwave background, I mean, that almost happened by chance because of scientists working on the early transmission of signals, and you could fast forward to today's internet, right?
Yeah, exactly. What happened was that soon after Sputnik launched, the United States science and engineering kind of leadership got together, and military leadership, and they realized Sputnik was really basically a nuclear warhead where the nuclear material was replaced by a radio transmitter. And you could detect it from anywhere on Earth, this beep, beep, beeping. And this is 1957. And they soon realized immediately that you could use this thing for communication in addition to using it potentially to drop bombs on America. And so American communications experts at AT&T here in America, New Jersey, really started working hard to understand what it would take to have a global satellite system of transceivers, devices that can both receive a signal from Earth and amplify it, and then transmit it down to Earth. Because of the Earth's curvature, you can't see from England to the United States. And they realized, rightfully so, that they wouldn't be able to line of sight with directed beams of energy communicate from distant places beyond the horizon. But they realized they could bounce it off things in space. So Bell Laboratories in America, New Jersey, started to collaborate with NASA to launch satellites into space. And one of the first group of these Telstar satellites was called the Echo satellite. And these Echo and Telstar satellites were placed in relatively low orbit, and they could be seen, a couple times a day from any location on Earth. And this type of transceiver could bounce energy and receive energy. And the problem was these two radio astronomers, who were hired not for their radio astronomical expertise, but rather for their ability to tease small signals out of background of insidious noise signals. And they were hired to see why it was that they weren't getting the signal to noise ratio, this critical piece of information that governs how good the communications link is between these two stations that are broadcasting and transmitting. And they kept finding that when they looked at the satellite with this radio horn antenna that I show in the book, that they could not get rid of a persistent hissing buzz and behind the satellite, and it was happening all throughout the year. And so what they did is very cleverly try to diagnose the source of this serendipitously discovered signal. And they did, in the end, come to a conclusion in collaboration with 3 or 4 researchers a couple of miles away at Princeton University who were cosmologists. So they were almost operating like radio engineers or electrical engineers, these two scientists, Penzias and Wilson, and they collaborated with cosmologists at the nearby Princeton University who were looking to find a signal just like this. And the interpretation that the Princeton scientists led by Robert Dickey came up with, which still holds mostly as true, although I'll point out the one key aspect that is not still held by most cosmologists. They said that this is a leftover heat signal from the formation of the first elements and the fusion of hydrogen nuclei, protons, into helium nuclei called alpha particles. So this fusion event, like fusion reactors on Earth or in nuclear bombs, releases tremendous amounts of energy. That energy, as the universe expanded, would have cooled off from the bright, blinding nuclear flash that they would have expected from the actual fusion event. But over billions of years, perhaps, and they didn't know the exact age of the universe, they just knew it was expanding and cooling, that signal could dissipate and be colder than the frigid depths of a South Pole morning. And it could be, in fact, just a whisker, just 3 degrees Kelvin above absolute zero. And that was the interpretation, that it was a cosmic signal, a background signal, meaning it comes in all directions, in all different directions on space, and we perceive it on Earth. And I said that the original interpretation is mostly correct, that it is a leftover fossil fragment heat signal from the fusion of the elements. But the one thing that they did not talk about really in their papers, this collaborative team at Princeton, who was trying to measure it, who was trying to win a Nobel Prize in some sense, and knew that they would lose their Nobel Prize race, as I talk about in the book, very painfully for them. But nevertheless, they only considered not the Big Bang that we know and love today, but that perhaps our universe was cyclical, that perhaps the heat was generated due to the collapse of a previous universe, and that the heat in our universe and our Big Bang merely emerged like a phoenix from the ashes, coming out of this rapidly expanding plasma of the nuclear material that came about thanks only due to the previous collapse of a prior cycle. We don't really think that that was the case. Most cosmologists don't think that's the case, but the debate is back again thanks to what's known as cosmic inflation. And maybe we'll get into that a little bit more as well.
Oh, I like the sound of that. So no Nobel Prize for detecting the CMB?
No, they won the prize for the serendipitous detection of the CMB, Penzias and Wilson. But the people who came up with the theory and the explanation for what it was did not win the Nobel Prize.
Got you. And this CMB, I mean, I was asking you about what's your day-to-day life as a cosmologist all about, and you're really striving, right? Correct me if I'm wrong, but to see that light from the earliest moments after the Big Bang, correct?
Yeah. So this is heat that's left over from the, people say that we're made of star stuff, that we are made of this dusty material, that we have iron in our bloods, and that's all true. That does come from.
Are you sure you're comfortable talking about dust, Brian? I know.
Yeah, I know. It's dust is the villain of my existence. Yeah, exactly. Well, the one good thing about the paperback is that you don't get that dust jacket, so you don't have to worry about the dust jacket falling off. That always vexed me. So go out there and get the paperback edition. You won't suffer that fate. So the actual explanation for what we're made of by mass and by number is hydrogen. Most of what we're made of is hydrogen, and that hydrogen really owes its existence to the origin and the origin of the cosmic microwave background. They are interlinked together, and that we're not just star stuff. We're kind of like universe stuff. We're more product of Big Bang because most of our matter in our body is water, and most of the water has hydrogen. Although all the water has hydrogen in it, and all of that hydrogen cannot be made in stars. It must have been made in the Big Bang itself. So we actually owe ourselves to that first flash of energy and heat. And what's so interesting is we're trying to discover, how did that take place? How did that Big Bang event, if it took place, again, it could, preponderance of evidence is that it did take place. But the question is, did it take place once, or did it take place as once in our current cycle of time, which is really fascinating to contemplate.
And is that one of the 5 debates that you cover within the book itself?
Yes. Yes, exactly. So I talk about these great debates, and these are really harken back to the very first one of these was held basically in the 1500s, thanks to the work of Nicholas Copernicus. So Copernicus stated that in his theory, he had very little observational evidence for it, but in his theory, in his conception, it was simpler to think of the solar system, which he called the world or the universe. He thought of the solar system as being centered on the sun, not the earth, as had been held for thousands of years before him, back, some say, to the Bible. I personally don't agree with that, but some do say that. But certainly the prevailing wisdom of the church at the time when Copernicus was active in the 1500s was that the earth was the center of the universe, and that owed itself to a misconception, one of many, by Aristotle, which was that the universe preferred symmetry was for things to fall downward and towards the center, meaning the center was sort of privileged, or the final stop, the center of the earth, the center of the universe, as your podcast is called, right? So if you had this natural propensity for things to go to the center, then it would be natural the earth should be the center, the most privileged place. Copernicus said, no, that's wrong. Actually, the sun is the privileged place, if you think about it. Later, Hubble and others showed that not only was our solar system not in a special place, but our galaxy was just one of perhaps hundreds of billions of galaxies. And now we believe that the universe could be one of hundreds of billions or an infinite number of universes in what's called the multiverse. And that's the latest in cosmic. Some, according to Roger Penrose, is a fantasy, and others, according to people like Alan Guth and others, is cosmic fact.
Yeah, I had Geordie Rose on the show, and obviously he's the guy behind D-Wave, and the team there, they came up with the first quantum computer, the first working one. I know there's more now. And he was talking about parallel realities as opposed to the multiverse, and he was very specific about the language. And I must admit, I find it fascinating to think about, Brian, but how on earth's name do we ever go beyond thinking about it to proving it?
Yeah, so that's a very, very important question. And it actually speaks to the heart of what scientists do. It's actually not true that we go around to prove things. I mean, you might prove things in the sense that you'll measure some property very accurately. How fast does an apple fall towards the earth? And the question of whether or not the electron's mass is a certain value or not. So, in that sense, you're proving, but you're really obtaining precision on what the universe is comprised of. On the other hand, if you're trying to ascertain the things that I'm most interested in, how did life come about from hydrogen? Okay, so we started the universe mainly with hydrogen. The only element on the periodic table back then would have been a single box. It would have been easy to ace your chemistry exams, and then to evolve to the rich chemical structure, and then from the rich chemical structure to Darwin's warm little pond is a very big step, and we don't understand that at all. And anyone who says we do understand it is wrong, or has an agenda. And there's nothing that should be wrong with that. It's a great mystery. It should be a delicious, delightful mystery to want to understand these great things that we don't comprehend about the universe. And so in our case, we're not trying to prove things. I'm trying to disprove things. I'm trying to prove theories wrong, and in so doing, leave a smaller and smaller region over which the universe could be considered to have properties that we know about with precision. So you want to be accurate, you want to know the answer and bound the answer, and you want to bound the answer as tightly as possible. But you're only throwing away everything that's outside of this region. You're not
Yeah.
actually proving something correct. I mean, Einstein proved Newton wrong, and someday we'll prove Einstein wrong. But there's
So,
nothing wrong with that.
so by process of elimination,
Yes.
theoretically, you're left with what is fact, the laws of physics, etc., right?
Yeah, exactly. So you winnow away the chaff from the wheat, and what you're left with should be this pure spun, cosmic gold. And in our case, we're trying to rule out different models of how the universe could originate. And I talk about those models in the book. The most chief among them is called inflation. But inflation, it's not healthy for things to have monopoly. I talk about how the Nobel Prize is a monopoly, that we get told all the time, that these Nobel Prize winners say they should be for Brexit or against Brexit or for Hillary Clinton or against Donald Trump or whatever. So they have a tremendous influence, and that's because they cultivated it through the Swedish Royal Academies. They've cultivated this aura of invincibility. Well, it's not good to not have a challenger, right? So imagine how boring the Olympics would be if there's no challenger. Imagine how boring elections would be if there's no challenger, or cricket, or here in the United States we're about to have the World Series coming up. So in all these things, competition is healthy. There is no competition, then things putrefy. In our case, we have this dominant model of how the cosmos formed, and a couple of people are working on an alternative theory that's very, very promising, but nowhere near as much investment in that alternative theory has gone in compared to the dominant theory. And so it tends to suck the oxygen out, especially for young people that want to explore additional and new and possibly creative solutions to the problem of how the universe began.
Now, is this a new theory that people are working on? Is this the cosmic inflation that you mentioned? I know we're really strapped for time, and we could probably
Yeah,
do a show on cosmic inflation itself. But
yeah, we
give us
should. Yeah.
give us the kind of headlines or the highlights from what they're thinking.
So we witness today every galaxy is moving away from us with a handful of exceptions. Every one of 100 billion galaxies is rushing away, some of them faster than the speed of light. And we can get into how that's possible some other time. But not only are they moving at some rate, which is actually well measured but controversial by two different groups, this is called the Hubble constant. And this is perhaps the most, roiling tension in cosmology today. How fast exactly is the universe expanding? And we get two different answers, and they disagree violently. It's like we can't call the race for for an indefinite amount of time. In this case, the universe is accelerating. It's also getting faster at its rate of expansion is increasing itself with time. So something that's twice as far away is moving four times away. Let's just say it's not, but let's just say it's moving four times faster than something else. Well, that rate would also be increasing, so that tomorrow it would be moving five times faster. You get it?
Yep.
So that acceleration of the universe is called dark energy, or that cosmic acceleration. Well, that pace of expansion that we see today corresponds to galaxies that'll be moving away at human speeds, faster than we can travel now, but tens of kilometers per second. But in the early universe, it was expanding faster than the speed of light, and yet we don't know how the universe is being caused to inflate and expand now, and we know almost nothing about how it was created or began in an expansionary state as well. And that theory is called inflation. We're really trying to discover the afterglow of that effect. We can't witness the actual effect itself, perhaps, because it's so distant in time, but there's one type of signal that we might be able to glean, and I describe it extensively in my book. It's called gravitational radiation from the Big Bang, and how it imprints this 3 Kelvin cosmic microwave background.
And talking of this book, the Amazon Science Book of the Year, no less. Well done, man. I mean, let people know where they can get a hold of the. Yeah, let them know where they can get a hold of the paperback and your website, and where people can follow you as well, Brian.
Yeah, so I'm fairly active on Twitter as Dr. Brian Keating, Dr. Brian Keating. Same from my YouTube channel and my Instagram channel. And I try to respond to questions and comments on videos that I've done throughout the years. I have a website, which is just Brian Keating, BrianKeating.com. The paperback edition should be out by the time people are listening to this, ready for order. And then I'm working on some new ideas for new things that hopefully I'll receive a generous invitation to come back and discuss. And these would involve all the different ways that we understand things creatively, consciousness, what I call the three big bangs that I'm most interested in is the Big Bang of the cosmos, then the Big Bang of life. How did life come from non-life, from hydrogen, as I said before? And then the last thing is, how did we go from life, bacteria, to Bach, or from rocks to Rachmaninoff, or whatever you like? How do you go from chemicals to life to consciousness? And these things fascinate me. I have a podcast called Into the Impossible. It's part of the Arthur C. Clarke Center for Human Imagination. Here's a glimpse of what that's called. And that's at imagination.ucsd.edu.
And Brian, honestly, I mean, this is so relevant to the conversations I have all the time. I mean, we often ask the question, what is consciousness? And at a time when we're creating machines that are intelligent, can they themselves become conscious? So, listen, we've got so much to talk about in the future. And I'm quite offended, actually, that you think you need an invite. You've got an open chair on the show anytime, sir. Just you get in touch. I will have
love
you
the show
any day.
I support the show, and everyone out there should do it too, because it's really, you have a unique product, and I'm so glad I could play a tiny role in supporting it. And I do hope I can come back in the future, Ken. Thank you so much.
You play a huge role, because I like to look at all sides of the debate, and it's good to go to some of the leading people in science to get that scientific
angle. Well, you are a
scientific,
you are like a scientific podcaster.
Thank you very much. That's just made my day. So, folks, check out Brian. Please check out the book as well. It's not very often you come close to winning the Nobel, then to lose it. And like he was telling us here, it would have been 50 years. I wouldn't have been around to find out that Brian Keating had ever taken part in any of this. So please check it out, briankeating.com. You can check out the book on amazon.com as well. And Brian, until next time, sir, you keep working hard on your projects. We've got so much to talk about, man.
We will. We'll do it again soon.